Hey everyone, welcome to today's lesson. Sorry that I couldn't be there in person today, but I figured the next best thing would be to create a video lesson for you so that way you can pause the video at any time. You could take notes, you could reflect, go back, do whatever you need to in order to learn the next lesson in Module 5. Today's lesson is called Applications of Slope and Distance. So now that we've been studying all about how to find the slope, how to find the distance between the 2 points, now we could use that in order to categorize triangles and figure out what types of triangles we're actually dealing with in a coordinate plane. And we're going to be proving that using distance and slope. Okay, so just as a little bit of a warm-up, I wanted to reiterate the distance formula here and the slope formula. So we're still going to be graphing things on a coordinate plane, so we still need to use these formulas to help us figure out the distance and the slope. So as a little bit of a warm-up for today, we're going to be given 2 points, find the distance, find the slope, and then talk about what it means to be parallel and perpendicular again. Okay, so let's start off with question number 1. If you want to try any of these questions on your own, by all means, pause the video, do this at your own speed. If you want to try it all first and then watch the video, that's totally fine. Or if you want to do it with me and then maybe the next, few other questions you want to try on your own, go right ahead. Okay, so for question number 1, it says that given the 2 points A, -8, 7, and B, 2, -5, we have to find the distance between those 2 points and the slope. Now, mind you here, we do not have a graph or any graph paper to actually graph the points. So we're so used to using Pythagorean theorem, but we do have this distance formula to also use whenever you don't have access to graph paper. So this will work no matter what. So the first question says to find the distance. So I'm going to start off the same way we would, let's say Emily would, right? And label our points. So the first point, I'm going to label that x1 and y1. And then the second one, I'm going to label that x2 and y2. And I apologize for how congested I must sound right now, but I'm still getting over this. So let's go. Let's figure out the formula. So distance is d for distance equals the square root, and underneath that square root, we have to be very, very, careful. It says x2 minus x1. So x2 is actually there too. So we have to do 2 minus x1. Now x1 is my first point. So -8. So 2 minus a -8. We're going to square that and then add it to y2 minus y1. So y2 is -5. I see that there. And y1 is 7. So in parentheses, -5 minus 7. And we have to square that. Okay, so distance equals, let's simplify. Those 2 negatives, right? We've been talking about that for a while. Those 2 negatives, right, Tatum? I always go to you for that. Those 2 negatives make a positive. Okay, so we still have that square root. Everything is still underneath that square root. So 2 plus 8. 2 plus 8, what is that? That's 10. So 10 squared plus, and then -5 minus 7 more. So those are both negative, so that means we're going to add them together. It's going to be a -12, and we're going to square that. Okay, let's keep going. Distance equals, okay, 10 squared, that's 10 times 10, that's going to be 100. 100 plus, and then -12 squared. -12 times -12 gives you a positive 144. And then if we add those two numbers together, we get that the square root is 244. Now, I can leave it like that because I bet you if I put this in my calculator, it's not going to be a pretty number. It's going to be a really long, irrational, answer with lots of decimals. So I'm just going to leave it like that. And that's my distance. If you wanted to put it in the calculator, you would get, what it is about. And since it's not a pretty number, we could leave it as the square root. But if you really wanted to know what it would be, about, you could put it in your calculator. And it's about 15.6. So, whatever you like, but the square root is a more exact answer. Okay, now let's go over to slope. Slope is my other formula over here. You see I put a little cloud around it so you can see it. So slope is m. M is equal to the change in the y over the change in the x. So y2 minus y1. So I'm so happy that we labeled our points. So we've got -5 minus 7. That's kind of like what we put in the parentheses for distance, right? Do you guys see that? -5 minus 7? And then on the bottom, we're going to have the x's. So 2 minus a -8. The same thing that's inside the parentheses, over here. So let's simplify it. Well, what did the y's simplify to? They simplified to -12. And then the x's, they simplified to a +10. So then if I simplify that a little bit more, I could put it right into my calculator, right? I could divide the top and bottom by 2, or I could have the calculator do it for me. I get a -6/5, and I can't go any further than that. So there's my answer for slope. All right, so there's a negative slope between those 2 points. And I'm done with question number 1. Okay? So hopefully you were able to follow along with that. Remember, as you go, you can pause it at any time. You could replay a certain section. All right? Do what you need to do for you. All right? Okay, so number 2. Number 2 says 2 lines are graphed. If the slope of line number 1 is 2/3. So that's a positive number. So 2/3, that's the slope. Then what would be the slope of line number 2 if the 2 lines were parallel? I want you to think back. Parallel lines. What kind of slopes do parallel lines need to have? Right? Well, parallel lines, they look like this. Right? They never touch at all. So in order for 2 lines to be parallel, they need to have the same slopes, right? So if line number 1 has a slope of 2/3, then line number 2 has to have a slope of 2/3, the same, in order to be parallel. Now perpendicular, that's a little different, right? Perpendicular lines, what do they look like? If one's going up, perpendicular means the other one's going to be going down. But it's going to be going down in such a way that it makes a right angle. Remember those 90-degree angles? So not only do these 2 lines have to have opposite slopes, but they also have to have something called reciprocal slopes. So not only do I have to make this one negative, but I have to flip the fraction around. So instead of 2/3, we have to have 3/2, 3/2. That's what would make lines parallel. Okay, so that's what we were talking about back in lesson number 1. Actually, lesson number 2 in this module. Okay, so you can also go back to your notes and refresh your memories. But that's for parallel and perpendicular. Now we're going to need to remember this stuff, all this information that we just went over for this topic. Okay? There's a couple other things we need to remember too. Moving on. Properties of triangles. All right, so the properties of triangles, this was way back in the beginning of the year. We talked about all these different triangles and what properties they had. So let's start off with equilaterals. I'm just going to change colors real quick. For equilateral triangles, that prefix right there, equilateral, that means that all three sides have to be equal, right? And it also means that the angles have to be all equal as well too. And remember that we said that they were all 60 degrees. Now today we're not going to focus so much on the angles of each of the triangles. We're going to focus more on the sides. Okay, so like today's focus is more about the sides. It's the sides of the triangles. Okay, so that's really where we're going to focus on today. So for equilateral triangle, I want you to remember 3 congruent sides. Remember that symbol, congruent? Okay, so that's what we should remember for that. For isosceles, isosceles. Remember, we have 2 eyes. So for isosceles, we've got 2 equal sides. Those 2 sides are equal, and also those 2 base angles are equal as well. But again, I want you to be concerned on the sides. We have 2 congruent sides. Okay, that's what I want you to remember for isosceles. And last but not least, scalene. Scalene, what I want you to remember for that is that we have no equal sides. See how I have 1 tick mark on one side, 2 tick marks on the other side, and 3 tick marks on the bottom there? That means that they have no equal sides, all no congruent sides. All sides are different. So that's what makes it scalene. Okay, so there's those 3 types of triangles. Those all focus on the sides of the triangles. Okay, mainly on the sides of the triangles. Now there's one triangle here. I'll put a little star next to him. This one has to do with an angle. Okay, and the reason why it focuses on the angle is because it's called a right triangle. And what makes a right triangle right is the right angle right back in that corner there. Remember that angle is 90 degrees. Okay, so the reason why that is 90 degrees is because a right triangle has 2 sides. I'll highlight them, the bottom side and the top side over there. Those 2 sides are perpendicular. Okay, perpendicular lines form right angles. Okay, I'm going to write that down. Perpendicular lines, that's the symbol for perpendicular, form right angles. Okay, so if this triangle was called A, B, C, okay, in order for this triangle to be a right triangle, that AC, side AC, would have to be perpendicular to BC, which is on the bottom. Okay, so AC, the one up and down, has to be perpendicular to BC, or CB, however you want to call it. Looks like an L, right? That perfect L shape, that would make a right angle. Okay, and where does that right angle come from? It comes from perpendicular lines. Okay, so there's one more triangle that also focuses on an angle, and that's the isosceles right triangle. See, that word right comes back just like that last triangle we did. A right triangle means we have that 90-degree angle right in that corner. But this one also says isosceles. Excuse me. It says isosceles. So we learned from the triangle above, right? Just needed a little sip of water. That 2 sides have to be equal. And those 2 sides are, excuse me again. So here we have it, isosceles right triangle. It's got two congruent sides and a 90-degree angle, right? And where does that 90-degree angle come from? It comes from perpendicular sides. So again, if this triangle, let's call this one DEF, right? If that's triangle DEF, then in order for this to be a right triangle, DF would have to be perpendicular to EF. All right, those two sides have to be perpendicular. Okay, now again, what does perpendicular mean? Well, perpendicular, going back to the very, like a little intro that we had, perpendicular lines have to have those negative reciprocal slopes. Okay, so 2/3. Oh, if I have to be perpendicular to 2/3, my slope has to be -3/2. Okay, so that's the warm-up. That's the properties that we had to review. I'm going to stop this video here just so that way you can, collect your thoughts, and then I'll make a new one for the next page. Okay, so that way everything is all broken up. All right, hopefully this wasn't too bad. I apologize ahead of time for the congestion and the coughing, but hopefully we went at a good pace and you were able to take down all the notes from this page. Okay, I'll see you in a little bit.